Hi, I'm Wendy Chung. I'm a medical geneticist and pediatrician and the principal investigator for Searchlight. I'm thrilled to be able to talk to you today about a condition called CSNK2A1 or Okur-Chung syndrome. I want to tell you about the data that we derive from Searchlight. This is an incredible study that we've been doing for about 10 years now. And with this, we've been partnering with family groups like yours to be able to learn together about how to support your family member to be the best that they can be. I want to describe very briefly what this is about. And for those of you who have participated, you are what I'm going to show you the data for today. And for those of you who haven't, we'd love feedback if you'd like to participate about how to make this easier for you. One of the things we do is de-identify your data, so no one knows who you are, but we then share that data with researchers around the world to be able to work for you. That is to be able to understand how they can help develop better treatments and supports for your individual and your family with CSNK2A1. So with this, I'm going to take some time to go through the data so that you can see and learn from this. But I want to tell you what the data represent so that you can understand what the limitations of the data are. The first step is that we invite everyone who thinks they have this condition to be able to come and share their genetic test report. And we do require that we review that to make sure that they're in the right club. So we started out in terms of this whole process for 63 people thinking that they should belong to this community. At this point, you'll notice there's a little gap here because only 47 so far to date have provided their clinical genetic test report to verify that right diagnosis. Almost everyone who thinks they have the diagnosis, in fact, does belong in the club. But I can tell you from personal experience, some people actually aren't in the right club, and we do help them to eventually get to the right club. So it's important to be able to know your correct diagnosis. After that, we have a couple different ways of participating. Individuals who participate come from around the world. We support individuals of many different languages, so we want to be as inclusive as possible. And one step within this is the opportunity to speak with a knowledgeable genetic counselor who knows about CSNK2A1. And we derive information from a medical history interview. And this is a really robust discussion reciprocally for us to be able to learn about the individual in your family and also for you to be able to talk with the genetic counselor to understand some of the genetics and some of the other aspects. In addition to that, and I will say that this is not a one and done study, but it's a long-term study. We're here with you all for the long term in terms of this. And to be able to continue that journey with you, we have mechanisms for you to fill out surveys online or instruments that I'm going to show the data in terms of behavioral issues and be able to do this over time on an annual basis so that we can understand how things change over the life course, because we know all of us change over our lifetime. In addition, I'm very happy to say that 13 individuals have provided a blood sample. And as I'll show you about in a second, that's gone on to be an incredible resource for the research community and has been critical. So again, long-term study, and you'll be hearing from us again if you are already part of the study. So let me explain what I mean in terms of these biospecimens. I'll also underscore all of this is a free service to the community. So we don't ask for any donations. All of it is free to researchers, free to families. We're literally helping to enable you to be able to push the research forward. The samples that you've provided us, and in some cases, these have been through family meetings, and I'm proud to say that we'll be having a family meeting in 2022, so next summer, next August. But in the past, we've collected blood samples at those family meetings, and they've been extremely helpful, especially for this top line here, to make what we call induced pluripotential stem cells. We've done this for 9 individuals, all at the expense of the Simons Foundation, totaling a cost of over $100,000 to be able to enable researchers to study brain cells in a dish. Taking a blood sample, we can then make that into something that is able to be made into any type of sample, any type of cell in the body. And that includes, importantly, brain cells. And those researchers can then do studies in a dish in their laboratory without having to expose a child, for instance, to a potential new therapy or new treatment. The researchers can first start by trying it in a dish where it's safe and they can figure out whether or not it seems to have the desired effect. So that's been an incredible resource, as I said, to the community. The reason why we've made so many different cell lines, 9 of them, is that this is a summary of all the different genetic findings we've seen in CSNK2A1 within the community. And just to show you that this column here indicates the number of individuals with the same change. And the reason it's blank in many of these cases is because there is, at least right now, only one known person, at least within the Simon Searchlight community, with that particular genetic change. So the point being, and I'll make this point very emphatically, that for many of you, the genetic variant is unique. That is that there's no one else who can represent you because you are unique. And so whether it's in terms of these blood samples, whether it's because of the information you provide us, if you don't contribute it, no one else can do it for you. On the other hand, there are certain individuals and certain variants. Let's take this particular one. This is a lysine at amino acid 198 replaced by an arginine. For this one particular variant, we've actually seen it 14 times in the community, and these are completely independent. So this doesn't mean we've seen it 14 times because you're all related. No, no, no. In these particular cases, this genetic variant has arisen new, or what we call de novo, in the individual with the condition and was not inherited. It started brand new with that individual, and 14 individual times arose brand new on its own. For some of the, in fact, the majority of these particular variants, we are sure cause O'Quark-Chung syndrome. The classification we use to designate that is that the variant is either pathogenic or likely pathogenic, meaning that we think it is associated with that condition. There are a few circumstances in which we're not 100% sure, though, and I want to be transparent about that. So as an example, we have one case here and one case here where these are variants of uncertain significance, or a VUS, variant of uncertain significance. And at this point, we don't have the level of evidence to know for sure that it's associated with the condition. Over time, I'm sure these will be reclassified, and then we will have more certainty that this in fact is the diagnosis and it's not something else. I'm going to report to you information on all the individuals here who have pathogenic or likely pathogenic variants. If it's a variant of uncertain significance, we've collected the data and we're waiting for it to rise up and be reclassified as pathogenic or likely pathogenic, and then we'll bring the data from those individuals in, but we wanted to make sure that we were giving you robust information. For those of you mainly who are researchers, I've put here just a pictorial in a line plot of the gene itself. Each one of these little dots represents an individual person, a different unrelated person. And what you'll notice is the height of these plots mean that we've seen multiple people, 14 in this particular case, again, with this particular lysine 198 arginine. You'll also note, as I said, that there are other places where we seem to have a cluster of particular variants. I'm going to come back to this in a second. And they're color-coded based on the type of variant. And so you'll notice that almost everyone for this gene has what we call a missense variant. And that simply means that at that amino acid, in this particular case, it's the number in the middle here, amino acid 156, there is swapped in and out one amino acid for another. An amino acid is a building block of a protein, and at this address 156, it's swapped in an aspartic acid and swapped out an aspartic acid and swapped in a tyrosine. You don't need to know all the particular details, except that one of the things that we eventually do want to understand is, do all of these genetic variants behave in the same way, and are they associated with the same challenges, or might there be differences between them? And again, we need to understand for you what you're seeing so that we can compare and contrast. Everyone above the line is one of these pathogenic or likely pathogenic variants I talked about before, whereas those that are below the line are still in variants of uncertain significance land. So we're waiting for them to rise up above the line if in fact there's enough evidence to do so. This is now a three-dimensional view of the protein. So the last way I showed you was the gene, and it's as if you just straightened it out and looked at that entire DNA strand. In reality, those genes are made into proteins, and those proteins then twist and turn, and they make a three-dimensional structure. And one of the things that I wanted to point out is that those missense variants, even though they might have looked like they were farther away from each other in those two different clusters, when it comes to the three-dimensional space, we do see that they tend to cluster in particular neighborhoods. And this gene is a kinase. It's a regulatory protein that puts a phosphate onto other proteins to regulate them. And it's very likely that these particular amino acids are affecting what the protein targets are for this kinase. And so there's a likelihood that many of these genetic variants will act in the same way. So there probably is some similarity, so that not everyone is unique. But again, we need to understand what those similarities and differences are. So this gives you some idea. You can twirl this around and be able to see how that works, but you can see the clustering of many of these. So now I'm going to switch gears, talk about the medical history. And I want to start out by saying that this is based on 27 individuals. That's a good number, but it's still only 27 individuals. And I'm showing here along the x-axis the age of the individuals and the distribution. This is showing a bar plot of how many. So we had one person who was 2 years old, 3 people who were 3 years old, and you get the idea. But the important part that I want to emphasize is the oldest person we had was 21 years old. So I don't have anyone here who's in their 30s or 40s or 50s or 60s. And so we do have some limitation in terms of understanding what this is like over the entire life course. We have, I think, a good sense of what it's like for young people before they get to adolescence. I think we've got emerging data for individuals who are in adolescence and perhaps young adults, but I don't feel like we have a good idea of what they are like as adults. So what are we primarily seeing? I'd say mostly what we're seeing is what I'd call above the shoulders. So it's the brain and behavior that we're seeing most impacted. This isn't any surprise to you. What we see mostly is almost everyone has issues in terms of developmental delay or intellectual disability. And this number is 88% and probably even closer to 100% if we think about some other different ways in which they're impacted. Almost everyone had problems with speech and language. And again, I would say that's part of this developmental delay that we see, but also some other behavioral issues as well. And again, this may change over the life course, but about a quarter of individuals with autism, about 20% with problems with attention, and I'll get to that later, and about 15% with anxiety. And again, this can change over the life course. As well, individuals had, again, when we think of the brain and behavior, many individuals had neurological symptoms. The majority of individuals had muscle tone that was low or hypotonia. Also had issues in terms of the head size when you take the measurements, a small head size, and problems in terms of movement. Problems where they weren't so coordinated, they were clumsy, they had difficulty in terms of being able to hop, skip, and jump or do more complex things like a dance move. Some of them, two, in fact, were diagnosed as cerebral palsy. I would actually consider that a misdiagnosis and actually update the diagnosis to be CSNK2A1, and a few others, again, infrequent, but with tic disorders or cortical blindness. Thankfully, it isn't the majority, again, is not the majority, but we did have a significant minority of individuals with epilepsy or seizures. So 10 individuals or 30%, 37% of individuals had a history of seizures. They were a variety of seizure types. So everything from grand mal seizures with tonic-clonic jerks to petit mal, something where you can be staring off in space and it may be difficult to recognize because someone isn't jerking around. Also, seizures associated with fever. These tend to be more benign or less concerning. But overall, again, a significant percentage of individuals with epilepsy or seizures, and it's an important thing to bring up with your neurologist or your doctor if it's never been a question before, just to make sure there's not something you might be missing, especially when it comes to, for instance, one of these petit mal seizures. In addition to that, thankfully, there were not big medical problems with 3 exceptions, and I think they're important ones to appreciate. Number one is that about half of individuals had problems with growth in some way. They tended to be skinnier, they tended to be shorter, not teeny tiny size, but they did tend to have issues in terms of, some people call it failure to thrive, some people think of them as thin or shorter, but again, some growth issues. Problems with tummy trouble, gastrointestinal problems, everything including diarrhea, constipation, gastroesophageal reflux, or heartburn. Those are the most common things people were seeing. Something that can be frustrating at times, but something also that can respond to diet, some toileting habits in some cases, and in some cases needing medication. Eye or vision issues were also common. This is an important one to know about. Most of you, I think, have already dealt with it, but making sure you're seeing, excuse me, a pediatric ophthalmologist or a special needs ophthalmologist is really important because it's sometimes hard to get and understand whether or not they're seeing things clearly because they can't necessarily read the eye chart the way you or I might. So with this, it's also important because if you can't see well, more prone to accidents, more difficulty learning. So we want to make sure that vision is as clear as possible. The other problems we were seeing are relatively infrequent, not things that I would say are serious, and many of the things that are typical in normal children. So not necessarily specific to CSNK2A1. In terms of medications, to give you some sense of how chronic the problems were or how serious they were because people needed to take medicines for them, not surprisingly, many individuals needed to take medication for seizures if they had had seizures. I'm showing you over here on the right the medications that people reported to us worked and were effective. What you'll notice is that it was only one person for each of these 4 different medications. So it's not clear to me that there's one clear winner in terms of a medication that's working for this, for epilepsy, but I did want you to see what we're seeing. Again, when it comes to GI, gastrointestinal issues, many individuals, about a quarter, did need to have some sort of medication, whether it was for a stool softener or problems for reflux or issues in terms of a laxative or something to be able to keep things moving. Those were quite frequent, as well as still a small number, but a certain number of people with attention issues. So let me move on to the third and last part, which is about behavioral issues. What I'm showing you in the next few slides is what I think of as a developmental growth chart. So it's age here on the x-axis, and then it's showing for each dot is a different individual, cross-sectionally what they're able to do over time. So in other words, each dot, we ask them at, for instance, at the age of 3 for this person, or at the age of 12 and change for this person, what were they able to do? These data, these graphs are based on 17 individuals, and what you reported to us with a standardized measure called the Vineland, and then I'm going to split it up into different domains. This is the expressive language development. So in other words, it's being able to speak or being able to verbalize and express yourself. So with this, you can see in a good way, this line is a line, sort of a best fit line across the data points, showing that there is development, there's growth over time. It's slower, we all know that, but there is advancement over time. To go from the point of asking or ask a simple question to being able to have more complex language with telling a story, even perhaps something like a 10-minute conversation. So again, I'm not promising that everyone will be able to achieve these milestones exactly on the ages that we plotted with these dotted lines, but to show you there's advancement over time. And if you wanted to see where your child was relative to others, we wanted to be able to give you this. So you could say, well, my child is about 5 years old. You know, what should I be expecting at this point? There are no other domains for the Vineland, things like personal care skills, how independent someone can be, and being able to learn some very practical things towards, excuse me, independence. This is again age on the x-axis here. Feeding with a fork and spoon or with utensils, being able to get dressed or undressed, some things in terms of hygiene, showering and bathing, and taking medicine independently. And again, in a very nice steady way, I see people gaining skills over time. Another area is with social development. So how well individuals interact with other people, play nicely, or able to communicate. And again, you see consistent growth over time, being able to start by imitating simple gestures initially, help doing simple tasks around the house, being able to help set the table, being able to take out the garbage, simple things, or I'm sorry, this is social development, being able to work together collaboratively in the kitchen, for instance, play dates with friends, activities with other children, but you can see nice advancement in those social skills. And then finally, gross motor development. So these are things like being able to run and hop and skip and jump. And again, what you can see is that over time, there's some variability. There's some are able to do things earlier than others, but being able to make nice advancements with this with increasing complexity of coordination and planning. So we did also ask about behavioral challenges. This is really good news to me. I was actually very pleased to see these results. We've broken these down by ages because there are different ways that we have people report for those under the age of 5. And for those, that age group, we had 14 individuals. And across these areas of different behavioral issues, the good news is that nothing was even mildly concerning. Everyone was in the no concern range for depression, anxiety, oppositional behavior, aggression, attention. Everyone was fine at that age. Now, children change over the life course. We all know that. So over the age of 6 to 18, so this is an older group, we had 19 individuals, and amongst them, we do start to see some mild concerns. We're just starting to get close to that mild concern zone. We are starting to see some issues with attention and hyperactivity. Remember what I said about that age range. We do have more children that are less than age 10. So this is an area that I'm watching closely to see, especially over adolescence. Does it stay in this area over here where we're either not a concern or maybe a very mild concern, or does it look like it becomes more significant as the children get older? I don't know for sure, but the good news is that it's not a significant concern. I'm also very happy to see that we're not seeing concerns in general about anxiety, oppositional disorder, aggression. We're just not seeing that, which is good. So in summary, for the younger children, less than age 5, there are some things that you've been reporting back to us in terms of being anxious or afraid of new things, getting frustrated, having some things that, really kind of freak them out in terms of either specific places or situations, and really being somewhat needy, being able to have their demands met immediately. For the older children, I would say, and this is in proportion, the sizes are in proportion of the frequency that we saw them, hyperactivity, restlessness, difficulty focusing, all major issues, but also continuing to demand a lot of attention and at times having tantrums or having emotional overflow. I'll wrap up by saying that we've also been looking for some of you over time, the same child at multiple time points as they're growing older. And so I call this a spaghetti plot. Each of the spaghetti strands is a different person, and we're measuring them at different time points. Again, this is with the child behavior checklist. So problems that might be of concern. Below this line, not a concern. Above this line, mild concern. Above the second dotted line, significant concern. The good news to me is that even for some children who had significant concerns to start with, take this one, this one, this one, in a good way, they've actually been able to get better, to overcome them, to learn some adaptive skills. So many individuals actually improved over time, even though they were getting older. And so I take that as really good news. And one of the things I hope that we'll be doing together is learning from each other about how to deal with some of those behaviors and how to hopefully get out of those ranges of concern. Okay, so to wrap everything up, as a reminder, we have a few common issues that I don't think will surprise you. Some language issues, developmental delay, low muscle tone, vision problems, hyperactivity, and less common, but still in enough individuals that I want you to pay attention. If you see any of these problems with autism, coordination issues, and issues with growth or gaining weight. So it was good to catch up with you and look forward to talking with you more later in the meeting.